Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about acid-base conjugate pairs and pH, how they're related to each other. Now, before we begin, we got to do a quick review on some of the things that are going to be important for today's lesson. Okay, number one is that we know what our strong acids and our strong bases are. So I've listed them up here on the board just in case you don't have them memorized. Okay. The second thing that we need to talk about is the thing that we learned in our previous video, is that there's a relationship between an acid and its conjugate base, or a base and its conjugate acid. If you have an acid-base conjugate pair like we're going to be dealing with today, if one of them is strong, the other one is going to be negligible. Okay, it's going to be at the very bottom of that strength scale. Okay, now if one of them is weak, the other one is weak as well, and there's this inverse relationship that exists with the strength of the acid and its conjugate base, okay, or a base and its conjugate acid. So if one of them is up here, like for example, if the acid is really strong, then the conjugate is going to be way down here, okay? If the acid started right here, then the conjugate's going to be right here, because there's this inverse relationship that exists when it comes to the strength of an acid-base conjugate pair. So I wanted to remind you of that. Okay, and then lastly, it's just the pH scale. It runs from 0 to 14. And if you want an easy way of remembering this, we count from small numbers to big numbers. And when we do the alphabet, we start with A, then to B. So the low numbers, okay, are going to be the acidic side, and the higher numbers are going to be the basic side. So what we're going to do is I'm going to put a substance on the board, and we got to decide what's going to happen to it when it dissolves in water. Okay, is it going to dissolve or is it not? Okay, and then after that, we're going to analyze, okay, things as being a conjugate acid or base. Okay, so let's get into our first problem, and then we'll ultimately determine the pH of that substance. So let's say I have some sodium chloride that I'm going to stick into water. Okay, the first thing I need to figure out, okay, does it dissolve? Okay, and that's where our solubility rules come into play. It has an alkali metal, so it's going to dissolve 100% into sodium ions and chloride ions. Now, these ions might be conjugates, okay, of acids and bases. Okay, so we need to take a look at that, and we got to investigate their strength. Okay, so we're going to start out with the sodium ion over here. Sodium ion is actually derived from this base, sodium hydroxide. And its ionization process looks something like this. Okay, so now here's the thought process. Okay, I have sodium hydroxide, which is on my list of strong bases. Okay, and if it's on my list of strong bases, it's going to ionize 100%, meaning the reaction only pushes to the right-hand side. We're going to identify this as a strong base. Okay, its conjugate, which is going to be the sodium ion. Okay, and if you don't know how to identify conjugates, you need to watch the previous videos. This sodium ion is the conjugate acid. Okay, so conjugate acid. Now, what we're trying to determine is the strength of that conjugate acid, sodium ions. Okay. Now, the way you do that is through this scale. Okay. We identified sodium hydroxide as being strong, so it means that the conjugate, okay, which is the sodium ion, is going to be negligible. So I'm going to label this kind of as a negligible conjugate acid. So remember, our positive ions are typically our acids, okay, our conjugate acids. And this one I have identified as being negligible. So I'm going to label this as a negligible acid because it is a conjugate of a strong base. Okay. Now we also have to look at the chloride ion. Okay. Where does the chloride ion come from? It comes from this process here of hydrochloric acid. And the ionization for hydrochloric acid looks like this. It has a single arrow because hydrochloric acid is on my list of strong acids. And if it's a strong acid, it's going to ionize 100%. It's going to push this direction. So we use a single arrow instead of an equilibrium arrow because this is a strong acid. Okay. Now, its conjugate, okay, is a substance that's present after the proton is donated, and that's going to be this guy here. This negative ion called chloride is the conjugate base of the strong acid, hydrochloric acid. And once again, if you don't know how to identify conjugates, you need to watch that previous video. But what we're doing in this video is determining the strength of this conjugate base, okay? Well, once again, if you have something that is strong, then its conjugate is going to be on the opposite end because of this inverse relationship that exists between an acid-base conjugate pair. So if you have a strong acid, then your conjugate base, it's going to be negligible, and it's not going to have an effect on pH. So I'm going to come over here, okay? I'm going to identify this chloride ion as being the conjugate base, and its strength is negligible. So I'm going to write this down as a negligible base. So if we had some sodium chloride that dissolved in water, okay, and we were able to stick a pH meter in there, what type of pH would we get? Okay. Well, if we had something that was a strong acid, okay, that would be down here at pH 0. Okay. If we had a strong base, we would be at pH 14. Okay. And as they get weaker and weaker and weaker, they get closer to pH 7. But I don't have strong acid or strong base up here. I have something that's a negligible acid, which means its strength is all the way at the bottom, okay? It has no effect on pH whatsoever. And then the same thing is true for the base. It's not affecting the pH. So if this is dissolved in water, it's just going to have a pH that's similar to water, a pH of 7, because we have nothing that's going to push it down into the acidic side, because this acid is terrible, okay? Nothing to push it on the base side because this base is terrible, okay? And there's no effect on pH when we sprinkle some sodium chloride into water and it dissolves, because both of these conjugates really have no strength whatsoever, and that's why we put them into the category of negligible, okay? Now let's do another problem. We got a total of 4 problems so that you can see kind of the differences between the two. So make sure you stick to the very end of this video, because each of these problems are going to give you a little bit more knowledge in this idea of how do you compare the strengths of these acids and bases, and how to identify these conjugate acids and bases, okay? So the next problem that we're going to deal with is going to be sodium fluoride. Now, I know sodium fluoride is also going to dissolve in water because of the alkali metal, okay? So it's going to dissolve 100%. There's not going to be any sodium fluoride present. There's just going to be these sodium ions and these fluoride ions. Now, we've already tackled half this problem because, look, we got sodium ions here and sodium ions here, and we know sodium, okay, is the conjugate of the strong base. And since it's a conjugate of a strong base, the conjugate acid is going to be negligible. So I'm going to come back here and just re-identify the sodium ion as a negligible acid, okay? Well, what about the fluoride ion, okay? Now, I know it's probably going to be a base because it looks like the negative ions tend to be basic. It looks like the positive ions tend to be acidic, okay? Not always, but there's a tendency there for this to happen. So where does the fluoride ion come from? Okay, well, it comes from the acid hydrofluoric acid. And I need to come over to my list, and this is why this list is so important. Do you see hydrofluoric acid on this list? Okay, and the answer is no, it's not on my strong acid list, which means it's going to be a weak acid. So I'm going to identify this as a weak acid. And if it's a weak acid, we are not going to use a single arrow. This is where equilibrium comes into play. Okay, so we're going to use an equilibrium arrow. And technically what this means is that really, I already know a lot about HF. It's going to tend to be on the hydrofluoric side. So like almost all of it, not 100%. It's probably like 96 or 97. So I don't know, but I'm just going to say it's mostly hydrofluoric acid. I'm just going to put an approximation there to say that, hey, it's mostly hydrofluoric acid. It's not going to make a lot of ions of hydrogen or the fluoride ions, okay? So if we have a weak acid, its conjugate, okay, which is a substance that's present after the proton is donated. So this right here is going to be the conjugate base, just like the chloride ion was a conjugate base. But now we got to determine the strength, okay? Well, this acid is weak, okay? So it's kind of like starting up here, okay? If the acid is weak, then the conjugate is going to be in that weak category as well. And remember, there's just this inverse relationship that exists between the acid and the conjugate base, okay? So if you start out strong, okay, your conjugate is negligible. But if you start out weak, the conjugate is going to be weak, and there's just this inverse relationship that exists. So I'm going to identify this as a weak conjugate base. So I'm going to come over here and label this as a weak base. And if we had some sodium fluoride sprinkled in some water, okay, and we had a pH meter in there to discover what the pH is, well, if you have if your acid doesn't do anything to push it down to the acidic side because it's terrible, it's negligible, okay, but you have a base that's a little weak, okay, that's going to push it up onto the basic side, I could say that we could probably have a pH that's slightly above 7, maybe an 8 or a 9, depending on a lot of different factors. One, the concentration of the sodium fluoride, and also how much the K value is for the hydrofluoric acid. Okay, of all of which we will determine like quantitatively in future videos. This video is just more about qualitative understanding of what's going on with these systems. So because we have an acid that has no effect on pH mixed with a base that does have an effect on pH, it'll rise the pH or make the pH level be a little bit above 7, maybe an 8 or a 9. Okay, got 2 more left. Okay, the next one is going to be KClO3, and we know that this is going to ionize 100% because of the alkali metal. So we got potassium ions and chlorate ions. Now, we know these positive ions are going to probably be acidic, and these negative ions are probably basic, but how acidic is this? How basic is this one? Okay, we got to kind of figure that out, okay? And it's all by thinking about where did they come from, okay? As far as like, are they a conjugate of an acid or are they a conjugate of a base, okay? So we take a look at the potassium ion over here, and I know that comes from KOH, okay? Now I got to figure out, is KOH on my list? Yes, it is. It's right here. And since it's on my list of strong bases, I'm going to label it as a strong base, and that's when I use a single arrow. So if it's strong, we're using single arrows. If it's weak, we're using the equilibrium arrow. Okay, so this is going to make my potassium ions and my hydroxide ions. And if this is the strong base, right here is the conjugate acid. Okay, and if this is strong, then the conjugate is going to be negligible. So that's a negligible conjugate acid, just like the sodium was a negligible conjugate acid. Okay, so I'm going to come over here, and if it's a negligible acid, I'm going to say, okay, this thing has no effect on pH. Okay, so it's not going to lower it down closer to 0. Okay, now I need to take a look at the chlorate. Okay, where did the chlorate come from? Well, it's going to come from HClO3. Okay, so for the positive ion, I'm just mixing that with hydroxide. Okay, for the negative ion, I'm just adding the hydrogen, and that's where they're derived from. Okay, now is HClO3 which is chloric acid, is it on my list of strong acids? And it is. Okay, so it is strong. So I'm going to use a single arrow, and I'm going to identify this as a strong acid. Okay, well, if it's a strong acid, then its conjugate is going to be negligible. And this is a negligible conjugate base of the strong acid, chloric acid. Okay, so if this is a negligible base, I'm going to come over here and label this as negligible base. And if we have two things that don't affect pH at all, well, this is just like the first problem, okay? We're back to something that looks like sodium chloride, okay? It has a negligible acid, negligible base, negligible acid, negligible base, no effect on pH, either going up or down. Well, this is going to remain at pH 7. So potassium chlorate, if I put it in water, it's not going to have an effect on pH because their conjugates are negligible because they're derived from things that are either a strong acid or strong base. Okay. Last problem is going to be magnesium chloride. Now, I do know that this one dissolves, but it doesn't have an alkali metal, so I have to go to the solubility rules of chlorides. And chlorides are soluble unless they're paired with silver, mercury, or lead. This is not silver, mercury, or lead, so it does dissolve. And it's going to dissolve into its magnesium ions and 2 chloride ions, okay? So when things dissolve, remember, you get coefficients, okay, not subscripts because they're charged, okay? Just a quick reminder on some of that older chemistry that we've done in here already, okay? So we got to identify both these magnesium ions and the chloride ions. Let's start with the negative ion because we've already identified it before. Chloride, okay, comes from the strong acid hydrochloric acid. So if hydrochloric acid is a strong acid, then its conjugate base, the chloride ion, is going to be negligible. So I know that already that this one is a negligible base. It has no effect on pH. It's not going to bring the pH up because it is a terrible, terrible base, and it will not affect the pH in the base direction, okay? Now, the other one, okay, is magnesium ions. So I'm going to stick magnesium with hydroxide, and then I'm going to check to see if it's on my list, okay? Do you see magnesium hydroxide up here on this list? The answer is no. So that means that this guy is a weak base. And if it's weak, we're going to use an equilibrium arrow when we do our ionization. Now, there's going to be 2 hydroxides here. And then we're going to identify the conjugate acid as being the magnesium ion. So here's the conjugate acid. And what type of strength does it have? Okay. Well, if it's derived from a weak base, then the conjugate acid is going to be weak as well. Okay. Remember, if you start out in the weak, you end in the weak. Okay. If you start out in the strong, you end up at negligible. Okay. So because of the inverse relationship. So if this is a weak acid, let's come over here and identify it as a weak acid. And if you see that as a weak acid and you're mixing it with a negligible base, well, you got one thing that affects it towards the acidic side, okay, the weak acid, and you have the base that has no effect on pH. Well, that's going to push the pH down then. If you have this affecting it towards the acidic side and this having no effect towards the basic side, you're going to end up with a pH of, I don't know, 5 or 6, and it's going to be dependent on a lot of different factors. But I do know that because this is acidic, it's going to be on the acidic side of the pH scale. Okay, so this is how we identified 4 different chemicals. We looked at the positive ions and the negative ions as seeing if their conjugate acids are weak or negligible, okay? And then the same thing for the conjugate bases, seeing if they're weak or negligible and determining the pH, okay, when we would dissolve that substance in water. If you found this content helpful, please give it a like and subscribe. And even when you add that comment, it does push this information out to other students that are interested in learning chemistry.